Your boss just walked in and said, "We need to get MCP working. I heard all the AI agents run on it now. Go figure it out and set up an MCP server." You nodded confidently, walked back to your desk, opened your laptop, and froze. MCP server? You are not even sure what MCP is. You search online and find 6 completely different answers for how to run an MCP server on Kubernetes, each one claiming to be the best solution. This video is here to help you cut through the noise. We will cover what MCP is, why running it on Kubernetes is harder than it sounds, what solutions exist, and which one your company should actually choose. Before we dive into solutions, let us take 1 minute to clarify what MCP actually is. MCP stands for Model Context Protocol. It is an open standard released by Anthropic in late 2024. In simple terms, it is a universal language that lets AI agents call external tools. Here is an example. You have an AI assistant and you want it to query a database, send an email, and run code. Before MCP, you had to write custom integration code for every AI system. With MCP, any backend service that speaks the MCP protocol can be used by any AI automatically. Today, almost every major AI tool supports MCP. Claude, Cursor, Windsurf, and OpenAI's GPT-4o is following suit. An MCP server is the backend service that exposes these tools. Your company might have 10 tools, each running in its own MCP server. Here is the core problem. When you put an MCP server into Kubernetes, you hit 6 walls. First, MCP's native transport is called stdio, standard input and output. This mode cannot scale horizontally in Kubernetes at all, because it assumes one process serves one user. Second, no session management. MCP is stateful. Requests from the same conversation must reach the same pod, but Kubernetes load balancing distributes requests randomly by default. Your conversation breaks. Third, no dynamic tool registration. Adding a new MCP server requires restarting the entire application. This is unacceptable in production. Fourth, no authentication or authorization. Anyone can call any tool. Zero protection. Fifth, no observability. You have no idea which tools are being called, how often, what the latency is, or how many are failing. Sixth, no traffic control, no rate limiting, no circuit breakers, no retry logic. These 6 problems together make MCP servers nearly unusable in enterprise environments. The solution is to put an MCP gateway in front of your MCP servers. There are 6 major solutions on the market right now, plus one build your own option. First is Microsoft's MCP gateway. Written in .NET 8, designed specifically for Kubernetes, with complete session affinity and lifecycle management. Highest score in our evaluation, 88.2 out of 100. Second is IBM's MCP Context Forge. Python plus Rust, over 40 plugins, and it supports 4 protocols simultaneously, MCP, A2A, REST, and gRPC, score 79. Third is Kong Gateway, the most mature API gateway with 43,000 stars, now with native MCP traffic governance built in, score 80. Fourth is Apache APISIX, open source, 16,700 stars with an MCP bridge plugin, but the MCP features are still under development, score 72. Fifth is Router by False Systems, written in Rust for extreme performance with only 7 stars, very early stage. Sixth is Dragon by Portaler Network, a Scala-based distributed architecture with only 4 stars. The Kubernetes deployment guide is not even written yet. Finally, there is the build your own option, using Go with the Mark III Labs MCP Go SDK. A basic gateway is around 200 lines of code with full control. Score 75.2. So how do you decide which one to pick? There are 4 common scenarios, each with a clear best answer. Scenario 1. Your company is already on Azure. The answer is straightforward. Use Microsoft's MCP gateway. It integrates seamlessly with Azure Entra ID, AKS, and Cosmos DB. One command to deploy from evaluation to production can take as little as 2 to 3 days. Scenario 2. You need multi-protocol support or strict security compliance. Choose IBM's MCP Context Forge. It is the only open source solution that simultaneously supports MCP, A2A, REST, and gRPC. It has over 40 security plugins, including secure injection detection and PII masking, and it is Apache 2.0 licensed, no vendor lock-in. Scenario 3. Your company already uses Kong for API management. The best move is to stay on Kong and enable its MCP features. You can even use Kong's MCP auto-generation to automatically convert your existing REST APIs into MCP tools. Scenario 4. You want lightweight and fast, or you want full control of the architecture. Build your own in Go using the Mark III Labs MCP Go SDK. It supports the latest MCP streamable HTTP spec, has zero external dependencies, deploys as a single binary, and is the cleanest solution for Kubernetes. Let us take a closer look at the technical details of the two strongest contenders. Microsoft MCP Gateway's most important design is session affinity. Here is how it works. When a new connection comes in, the gateway randomly selects a pod. It stores the mapping between the session ID and that pod in Redis or Cosmos DB. All subsequent requests with the same session ID go directly to that same pod. The session key is scoped with the user's ID as a prefix, defending against cross-user session hijacking. Its Kubernetes architecture uses a stateful set with a headless service, giving each pod a stable DNS name. This is exactly what makes session affinity work reliably. It also has 3 layers of network policy. Only the gateway can reach MCP server pods completely isolated from the outside. IBM MCP Context Force strength is in security. Its JW tokens have a validity of only 5 to 20 minutes, extremely short by industry standards. It also implements a server-side token block list. When a user logs out or goes idle, the token is immediately blacklisted and becomes unusable, even if it has not technically expired yet. Both solutions offer enterprise-grade Helm charts and support horizontal scaling. The key difference is Microsoft goes deeper on MCP specifics, IBM goes broader on protocol support. If you want to avoid vendor lock-in, Kong and the build-your-own-Go approach are both worth serious consideration. Kong's biggest selling point is MCP auto-generation. You describe your existing REST APIs to Kong, and it automatically generates the corresponding MCP tool definitions. If your company has dozens of existing APIs, this feature alone can save enormous amounts of work. Kong also offers complete observability, semantic caching, semantic routing, and support for multiple LLM providers in one platform. The downside is that enterprise features require a paid Kong Connect subscription. The build-your-own-Go approach is built on the Mark III Labs MCP Go SDK. It currently has the most complete support for the latest MCP streamable HTTP spec. Streamable HTTP is better suited for Kubernetes than server-sent events because it does not require persistent connections, making load balancing and horizontal scaling much simpler. A basic self-built gateway needs just a few things: create an MCP server, add middleware for authentication and rate limiting, deploy it as a Kubernetes deployment, and add an ingress. The whole skeleton is around 200 to 300 lines of Go code with 0 external dependencies. This is ideal for rapid initial validation or when you need deep customization. Now you know the options. Setting up an MCP server is not a single choice, it is a decision matrix. If you are on Azure, you can start deploying Microsoft MCP Gateway today. If you need multi-protocol and compliance, IBM MCP Context Forge is worth a week of evaluation. If you already have Kong, turn on MCP and start generating tools from your REST APIs. If you want maximum flexibility, build your own in Go with MCP Go. 200 lines of code, running today. The MCP ecosystem is maturing fast. 2026 is the critical year for enterprise adoption. The earlier you move, the better positioned you will be in the AI agent era. I'm Dennis. See you next time.